everything in this course is about intuition, right? It's very difficult in theory of machine learning, or at least we don't see that in books. So you don't have books on theoretical machine learning. You just don't have that. I mean, there's 120-page book by Sanjeev Arora, but that's pretty much not theory in theory per se. Anyway, so everything is intuition based. Why do we have this particular cost function? Can you change it to something else? Yes, you can. Okay. So you can change it to something else, but then that has to be justified more than this one. And it turns out that this is a reasonably good function to talk about. One of the biggest properties why we keep this particular function as a cost function in this case is that it is convex. We won't really go into this theory of optimization, but what does convex mean? For us, convex is a very simple thing. So essentially for us, there will be only one minima, and since there is only one minima, that is also the global minima. So this is what we have. Now this is the cost function. As I said before कि भाई ये वाले जो अपने three curves हैं, they are important. For linear regression, we will make use of all three of them. In fact, for linear regression in just one variable. The moment you start increasing variables, or the moment you start increasing dimensions, right, these two will not help us much. What will still help is this guy, and this is one that everybody keeps drawing in machine learning. You must have already done this particular thing before. Okay. So we'll start with this now. Our question, so what we had done until last class was, we had decided on that this is going to be our cost function. Okay. Just a second. View to iska sahi hai na? Haan. So we had decided on a cost function. How does cost function here look like? It's a parabola. This is a parabola. It's going to have one minima, right? Now for, let's say, red line corresponds to, no, not red line, but this line, right? Let me call this as line number 1. So line number 1, let's say it corresponds to this particular value of W, right? I can see here, so right now I am going to use this particular freedom. Here I can see it here. Let's say I can see it here, this W, this particular line 1 is corresponding to this W1. How can I improve? देखो, if you don't understand these lectures, आगे के things will only become difficult and superficial. Whereas I claim nothing is difficult in this course. It's going to be a bit, थोड़ा सा attention मांगेगा, but other than that, nothing. So if you understand linear regression properly, this whole thing will go easily. बीच में RNNs थोड़ा सा आएंगे जब अपन vanishing gradients की बात करेंगे. Other than that, everything will be smooth. So coming back to this, right now I am at this W. Why am I at this W? How many of you know why we are at this particular W, or any other W for that matter? How many of you know what are we trying to do? Raise your hands. What exactly are we trying to do? How many of you have no idea what we are trying to do? Okay, no idea? This is linear regression. This is something you must have already done in machine learning, right? So थोड़ा सा याद है उसका? मतलब usually तो अच्छा खासा टाइम हो गया, 1 साल हो गया? नहीं, 6-7 महीने और 1 साल हो गया, चलो. All right. So we start from here. We need a best fit line for this data. We had defined bestness. कैसे bestness define की थी अपन ने? देखो यहाँ पे एक लाइन बहुत सुपर इंपॉर्टेंट है. It is this. Can you have a single straight line passing through all these points? You can't. So you are certain to have a non-zero error, right? There does not exist any line which can pass through all these points, and hence you will have a non-zero error. Because if you could have a zero error, this would mean all these points are collinear, and most likely you would not be doing machine learning in that case, right? You would know by looking at that particular data that this simply fits into a linear straight line. That's it. Now, so we are still looking for a line, and then we want to claim this is the best line. Now, how do you define bestness? We talked about this yesterday. We define bestness in terms of this cost function, right? This cost function could be something else, but you see this particular cost function has some important properties. Now, what I will do is I will make it this way, y hat, and then right. So, what are the important properties of this particular cost function? Differentiable, fine. The most important thing is it is convex. So, I will loosely draw it. So, this is how it is. Now, how do you do machine learning? Let us start with that now. These are something that should be by heart. So, what is gradient descent? No, what is the algorithm? Can anybody help me write? So, until convergence you do something. What do you do? This is a complete training loop. Compute J. Okay. Compute J. What are you going to compute next? So, you need to compute grad J. And then finally what do you do? Update. So, what are these update equations? So, I usually like to write it update, and the update equation is W equal to W minus alpha grad J. Now, एक बात बताओ, in case of this simplest example that I could have taken, how can I draw this network? Network is this, X, W, and this is my output, Y hat. I have already made bias go to 0. This is my neural network, right? One variable, so one input, one parameter, and that's it. So right now my Y hat is nothing but Wx. So I can do everything in 2D. Okay. Now, how do I run this algorithm in this case? Maybe this much is sufficient. Yes. So let's say this is my W axis, this is my J axis. I want you to help me out with this algorithm. I want to go to right place. What is the right place for me to go here? एक बात बताओ, how will this algorithm run? What do you mean by until convergence? W will, right. So by convergence we mean you stop updating. What is it that you are updating? W. So all these terms are analogous until convergence. In some places you will find the learning has stopped, right? When will learning stop? When the value of parameter will stop changing, right? The learning has stopped. Now in this very simple example of ours, J is this, I'll rewrite the J when we'll differentiate, okay. Now J is this, grad J. Can I simplify this grad J right now? For this particular case, it is not a gradient actually, it is something simpler, and that is actually dj by dw. Because it's just one variable, I don't really need partial derivatives and all these fancy things. So it is just this, but I'll still call it grad J, okay. So then this equation is very simple. Now help me, how will this algorithm help? What are we supposed to do? When you say until convergence, what do I do? You were saying, somebody was saying something. Start at some random W. So start at some random W, let's say this one. What is the probability that this particular W is same as the point where you have minima? What is the probability that I'll start with the optimal point as a random initialization? Zero, right? Because you have infinite points, this is a continuous differentiable curve, you have 0 points, so basically 0. You won't start from here. Now, W, alright, this is W, and then that now analogy comes in. Ki bhai, you are in a hill, okay, and you start descending from there. I like the analogy of a wire in this case. You have a wire, right? जो कपड़े सुखाने वाली तनी सबने देखी है ना, right? ज़्यादा कपड़े डालते जाओ, starts coming down, right? That kind of a wire, right? Because that you can see in almost 2D. It is still not 2D because उसकी भी कुछ thickness तो है, but assume it is in 2D. So that is what it is. And अब come to that same plane of that string, right? This is the plane we are talking about. इस geometry में किसी को कोई problem? So let's say if this, I have one point here, I have another point that side, and I so tie a string at both these ends. It will lie in this plane. This is what I am talking about. Okay. Now, so if this happens, I start from here. Where do I intend to go? Why? Why do I want to go to minima? I want to go to minima because what is my original task? I want to minimize this cost function. What was cost function representing? If I minimize this, I basically minimize the fact that this error will be minimum. Okay. So I need to go to minima. I need to come here. Let's call it W naught. You have to help me with this algorithm. I want to reach there. How do I do that? You will see so many lectures where people will say we climb from here, here, here. I personally don't like this analogy, because then we are thinking we are here in this space. We are actually not. Where are we? We are just in this space. By what is our variable? W. So the only degree of freedom you have is this line. You can either go in this direction or you can go in this direction. There is no other freedom. So when we start doing like this na, I find it very confusing, because then we see we are walking here, you are not walking here, you are walking here. Okay. So I am right now here, and right now, since I will leverage this fact that we can watch it, so I need to go to left hand side, right? Okay. If I were starting from here, I need to go to right hand side. So I won't actually start here. Where will I actually start? Because I will choose some value of W. So I will actually start here. I will always remain on this line. This is all I can do. I can't really move there. So wo jo tha na, steepest thing, I don't like it. Now next. So let's say we start from here. This I'll come to later. We start from here. I should go towards left. How does this algorithm ensure that? So how do you define a gradient? How many will say slope? So gradient is much more general thing. Okay, I'll talk about it when we'll talk about 2D variables. I'll come to that later. But right now, this is just, so dy by dx. Okay, in this case, dj by dw. Let's start from here. What is compute j? Let's say you have computed j. For the sake of simplicity, assume there is just one example. We get rid of a lot of things here. Okay, so compute j. How do you do compute grad j? Differentiate. Right now I am not going into differentiation, we will do it after maybe some 10 minutes. So you computed the differentiation. In this case it is exactly dj by dw. Okay. Now what is this equation? W equal to w minus alpha grad j. What is alpha? Learning rate. Right. So alpha is learning rate. Alpha has to be strictly greater than 0. It cannot be equal to 0. Alpha has to be greater than 0. Now, when will the condition of convergence come? When will the condition of convergence come? When W stops updating, and this can happen only when grad j becomes 0, because we have ruled out the fact that, we have ruled out the possibility that alpha is 0. Alpha cannot be 0, hence this guy has to be 0. This guy will be 0 in this case at only one point, which is minima. It's a convex function. It has only one point where grad j will be 0. So this is the point. So when we say until convergence, when we say learning has stopped, at which point it will stop? When I will reach exactly W naught. Okay? Any questions here? Dekho, stop me for however small you think the doubt is. So when you reach here, you stop. I am here, we start doing it. So let's say we start doing it step by step. When I am there, what does the knowledge of calculus tell you? My dy by dx is positive or negative? Positive. My dy by dx here is positive. In this equation, this is positive, this is positive. So if I start from here, which direction will I go? I will go to left. Okay. Now when we say gradient is the direction of steepest increase of a function, in this line if you see there are only two directions available to you. You can either go to right or you can go to left. So right side is the direction of steepest increase of value in the function, and the opposite one is the steepest descent. Okay. So you have it here. Now let us say alpha was whatever and we end up coming here. What happens? We have updated W. So now W1, say let us say we have come to W2. What happens now when we are here? Compute J, compute grad J. This time grad J will be different. I mean, in general it will be different. You do that. Is still dJ by dW positive? Yes. I will keep on moving in this direction. Will I ever reach W? W naught? So in practice you will never reach W naught, okay, because you might become closer to it. By the way, why did you say we won't reach? Whosoever said we won't reach, why? Exactly, but why? Right, because you are trying to hit to a point, right, and it will be impossible to hit to that particular point, right. So what will you eventually need to do? See your grad J, so why am I reaching towards W naught? Because if you see your grad J is slowly becoming 0. It will never become exactly 0. It will become 0 such that in your computers the value has become so small that that word length stores all zeros, let us say. So this becomes 0 for all practical purposes. This becomes 0. What happens next now? I update W equal to W only, and I was supposed to run this loop until convergence. Have I hit the convergence? Let us say I have reached W naught, so then we are done. On the other hand, let us say you start from here. If this is your starting point, then what happens? If your starting point is this, then what happens? In this equation you have W equal to W minus alpha grad J. Grad J is negative, so this will become positive and you will still come towards the minima, okay. If you have this visualization, exact same thing is happening even in 1 million dimensional vector space, right. Nothing special happens there. If you have this visualization, this is what is happening. Anything that I am forgetting to do? Any comment, suggestion, questions from your side now? You guys tell me. If you keep alpha fixed, by the way, yes, there is one important thing, thank you for this. So if alpha is very close to 0, what happens? So I want to draw this spectrum now. So let us say alpha equal to 0, but it will never become 0, so alpha lies between 0 to infinity, let us say, okay, and this bracket means not included, okay. So tell me, alpha is 0, so we start from 0 plus epsilon. What happens if alpha, value of alpha is very small? If value of alpha is very small, your change will be very small. It will take you a very long time to reach W naught, and how do you call that in machine learning terminology? Learning is slow, okay. Learning is slow. On the other hand, if you keep alpha greater than some threshold, let us say you keep it very high, okay, what will happen in that case? So how does it shoot out in this case? You are here right now, W equal to W minus alpha grad J. Now let us say this alpha is too high. Where will you end up being? So on this line you will come somewhere here, let us say, and this goes and intersects at J at a very high point. Okay. So this overshoots whenever you just pass this point. So value of alpha has to be chosen very wisely, but usually there are fixed values for it. In general, algorithms like Adam and all these, they keep a variable alpha. As you approach towards convergence, it starts decreasing alpha. Okay. Any questions now? Yes. Fine? Chalo. Now J was, I'll simply just write JW. What was JW? 1 by 2m I is equal to 1 to m h, not even h, in this case how should I write it? Wx I minus yi whole square. Is that right? Seems. How do I compute grad J? How do I compute grad J? So grad J in this case is dj by dw. You have to help me out, मेरे को differentiation नहीं आता. Yes? So first of all tell me how many are variables, how many alphabets are variables here? M is a variable? No, right? It's the fixed number which is the number of training examples. So M is a number that is fixed, you will eventually put a number here. What about yi? That's again a number, it is coming from your CSV file, right? It is the label of that particular example. Xi, the input of that. So all these are numbers except W. Help me differentiate. So 2 dot 1 by 2m. Do I have to touch this 1 by 2m? Right? It's constant with respect to W, just goes out. What about this guy? Can I simply take differentiation inside summation? Okay. So what do I do here? Summation I is equal to 1 to m Wxi minus yi. Is that right? Into xi. Xi, right? सही है, हाँ. Okay. How does it help me? This is my differentiation. Plug those values there and keep on doing this until convergence happens, until your W stops updating. Okay. Now, any questions until now? भाई किसी को कोई चीज नहीं समझ में आई हो तो it is the right time to ask. All right. So you have done linear regression before, कोई चीज जो मैं मिस कर रहा हूं? Then what I'll simply do is, हाँ हाँ I don't want to do that. That's why I changed it. You know, it's a square thing. I want this. This will only make your calculus a bit more complicated. That's it. Okay. So in that case, what will happen if this goes this side? You take square, right? So I mean, you can handle it, but things will be a bit different. Huh? So instead of writing, you know, x minus 2 kind of thing, you will be writing 2 minus x kind of thing, take square, handle that properly and so on. Okay, now I want to increase the dimensions. Okay, so what will be the end result of this whole exercise? Once you have reached a W, what happens to these curves, these three curves? How will these three curves look like in this whole process that we have just described using gradient descent? And can you solve this equation analytically? You can, right? There are equations where you just plug in and you can solve this analytically. But I'll come to that, or maybe not come to that. So what happens to these? What will be these things? Every iteration of the loop. Okay. So let's say the value of j was highest at some point and then it starts decreasing. This is the best thing for us. If this won't happen, in which case will I see oscillations? In which case will I see oscillations? When you take alpha to be too high, let's say, it overshoots, value of W will actually increase rather than decreasing. Then you come back, you maybe come closer and you keep on doing this. Okay. What more? What happens in this case? So assuming we started from here, we have a nice alpha, we are going towards this side, this original white and red curves will look like. Now what will be the end result of this whole algorithm? We will get this best fit line, which we are claiming is not red one really, but someone this one, right? I want to bring it that intercept in now. So we want to have B now. So how will my equation look like? Does it have any impact on this algorithm? Right, so this is something I like to ask in almost every class that we'll start with. Right. So now what do we do? If I have, so since everybody has understood everything, okay, what happens when we increase the number of variables from 1 to 2? So we have this same network, one parameter, I mean one input, one parameter, but now one bias. So we have equation not y hat equal to wx now, rather what we have is y hat equal to wx plus b. Do this. How will this algorithm run now? What are your contours in this case? Contours means all those values of my variable where j takes the same value. In this case, what are the contours? सब समझ गए कि कंटूर्स क्या है? कंटूर्स आर दोज थिंग्स where value of j remains the same. What are they in this case? बोलो बोलो बोलो. Right. So your contours in this case are all straight lines that are parallel to w axis, x axis, w axis, right? Because you won't have circles here because it's just a 1D thing. I have just one variable, another variable is my dependent variable, right? So just it's a plane, you can't have circles. So all lines that are parallel to w axis will give me contours. Now what happens in this case? So basically all these lines and so on. What happens in this case? You have to run gradient descent in this case now. Now you see, you have this one j. So your j is wb, this is your w, let's say, and this is direction b, this is perpendicular, and so on. So it's a 3D thing, this kind of a thing. This is j, sorry, this is j, this is, let's say, w, this is b direction, right? So I can't draw it on a 2D anymore. But my question is, now you have non-zero w, you have non-zero b, right? How will my j now look like? That is my question when I say y hat is wx plus b. How will my cost function look like? There is hardly any change. How will this thing change? wx plus b. Okay. So in this whole thing, there will be only two variables. What are they? X and y need, w and b. Okay. W plus b minus y whole square. How will this function look like? So let me explicitly write it for you. In this case, my jwb becomes right. So in this case, only variables are w and b. You have squared it. How will that whatever resulting function look like? In this case, it was a parabola. What is it now? Circle. Equation of conic section कितने को याद है? General equation of conic section. General equation of conic section, ax square plus 2hxy plus by square plus 2gx plus 2fy plus c. Okay. When is this a circle? H is 0 and A equal to B, because if A is not equal to B, your axis will be not aligned. Okay. Now, which term will be missing in this case? Or how does it look like? Chodo ye sab. Conic section, it looks like a bowl shaped function. For example, what we had here, okay, it's basically a parabola in 2D. What you had here, rotate, isko ghuma do, right? So once you start rotating it, whatever comes, that's how this guy will look like, roughly. Okay, so it's a bowl shaped function, ekdam kadhai type se. Okay, extend this kadhai to infinity. So that is how your this bowl shaped function look like. अब मेरे को बताओ, how will you run gradient descent in this case? कहाँ से शुरू करोगे, कहाँ पे नीचे उतरोगे, किधर दौड़ते जाओगे? You are in a real space that we experience now, right? If you will, I mean, if you ever go to a hill, see, on earth, right? Assuming that this particular piece is flat, so any infinitesimal small place is flat, let's say on earth. So I am standing here, this direction is, let's say W, this direction is, let's say B, and this height is in J direction. You have to tell me, how does my J look like now? Earlier it was easy, it was a string, it was a thread like this. How does J look like now? So put the minima of that kadai somewhere here, okay, and extend it to infinity. You can think of it in other ways. Let's say I have an infinite, क्या होता है वो शादियों में लगाते हैं ना, तिरपाल, right? हाँ, tent. So now let's say you have an infinite one, okay, and उनको 4 corners पे आपने कहीं पे लगा दिया है, right? उसको hold करने के लिए we will need that 4 corners, else theoretically not needed. So it will take this shape. That's the shape we are talking about, okay? Or you can assume you are into a hill and you want to go downhill. मैं जो समझ में आ जाए, बाउल समझ में आ जाए, कढ़ाई समझ में आ जाए, तिरपाल समझ में आ जाए, कोई भी एक चीज जो तुमको दिमाग में समझ में आ जाए. Now, what are the good properties of all these shapes that I have talked about? Huh? They are all convex. There is only one minima and you want to reach there. But it becomes a lot more complex than this one. And I think, so we'll just motivate this and we go. Maybe 1 more minute, that's it. So देखो, instead of drawing it, एक सेकंड जल्दी से तुम लोग ही लेटे रहो. Instead of drawing it this way, I am standing here, this direction is W, this direction is B, they both are perpendicular to each other, right? And so ये जो plane है, this WB plane, that is my degree of freedom. By anywhere on this floor I can walk, right? So my variables are W comma B. Earlier it was just a straight line. I couldn't move other than that. Now you are here, you can walk on this particular plane, right? So whenever we basically walk on earth, this is our exact same thing, okay? Now, height of your mountain, height of your hill may very well represent a cost function. Okay? And how do we come downhill from there? We will start this in the next class.